So, welcome back to another lesson in the Ultimate CCNA Prep course, where we are prepping you to take your CCNA exam so you can increase your income, right? And that income can rather be in your job. Maybe you want to go to the IT department at your current job or just get an IT job. Or you want to sell your skills on places like Upwork, Fiverr, or just creating a business out of it to where you're doing something like contract work or something just for yourself, right? So we're actually in the last lesson of the CCNA exam topics, last section, not lesson, let me correct myself, section, which is six. Section 6 is all about automation and programmability, right? So today in this lesson, we're going to be discussing 6.5 and 6.7. So we're going to talk about REST-based APIs, because we already talked a little bit about APIs, but specifically today, we're going to talk about REST-based. And then we're going to do a little bit of JSON. We're going to learn how to interpret JSON, okay? So let's get into it. All right, so what is a REST-based API, right? So we already know that, let me get this out my way, Sorry, you guys. I don't know why I just let this sit here. Anyway, so we already know that an API is an application programming interface, right? We know that. And it's a set of rules that allows one program or software to talk to another program or software, right? So we create this API on a server, and that server is going to speak to the client, and the client can speak to the server through this API, this programming interface, right? So REST, R-E-S-T, determines how a specific API, what it looks like, right? How it behaves. Now, REST, as you can see right here, stands for Representational State Transfer, right? Representational state transfer. That's what REST stands for, right? And it's just a set of rules that we use, most likely developers, but as you are in network engineering, you're kind of like halfway a developer, right? So it's a set of rules that developers follow when we create an API, right? And specifically when we want to create a REST API. And one of those rules is just saying that we're going to use HTTP requests to access and use data, right? Use HTTP to request and access, access and use data, right? So when you think of it like this. You want to go, let's say you are on YouTube, right? And you're looking for Harry Potter movies. Let's say you're looking for Batman, right? Looking for Batman, and you put into the search and you type in Batman, right? In the search field, you press enter, and all these Batman videos, Batman related videos are going to pop up. That is exactly how the REST-based API works. It's a similar way, right? So we're going to search for something, right? And we're going to get a list of results back, and from what we're requesting, and we're going to choose which one we actually want to use based off what we're trying to do, right? So that's essentially a REST-based API, right? We have these rules that we want to get a piece of data from, and this data is called a resource, right? And that resource is going to be linked to a specific URL, right? That URL is called a request, right? And like an HTTP request, right? We're going to request some data, and when the data is sent back to us, it's going to be called a response, right? So request and response, okay? That's how that works. If you look at here, the nice little image, look at here, we have the client. The client's going to say, hey, I want to get some information, right, through an API. The API is going to talk to the server. Server's going to say, well, this is the client is, well, the API is going to say, this is what the client is requesting. And the server is going to send a response back to the client on what you're requesting. Again, think of it as a simple YouTube search. I'm looking for Batman videos, right? I'm just saying Batman, and it's going to pop up with the most suggested or recommended Batman videos for me to watch, right? I can get more specific on what type of Batman, funny Batman, the Batman movies, Batman cartoons, classic Batman. Like I can get more detail, but it's going to send me information, right? It's going to give me a response, right? A response, okay? That's all that is to it. Okay. Now, in order for an API to actually be considered a REST-based API, it has to follow these 6 rules. Okay, let's go through them. So we have, hold on, this just pops up. Okay, so we have client server. That's one rule. I'm sorry, this thing is popping up. I don't know. Okay, go back. So we have client server. That's rule number 1. So we have a client who requests, who's going to request for resources, and then we have a server who has the resources. Okay, so if you look at it, just simple. We have our client, have a server, and our client is going to say, hey, I want something, and our server has it and is going to send it back and say, here you go, here's your response. Okay, that is client server. That's the first rule. Second rule is, so we did client server. Second rule is stateless. Stateless, it basically says what kind of commands that can be offered between the client and the server. So what stateless means is you're going to have to repeat the request in full if you want it. So for an example, let's say I am requesting to know the status of the interface, right? Status interface is G0/0, right? So the server is going to respond and say the status is up, right? Now, I'm going to have to go back and request, I'm going to have to request the protocol. I'm going to have protocol on interface G0/0, and it's going to give me the protocol. That's stateless, right? If it was state full, I can say, give me the status of G0/0, and it's going to say, it's going to give me a response is up. And then I can say, what protocol is it running? What protocol is on there, right? What's the protocol? And state full, the server will say, oh, well, we have OSPF. But stateless means that I have to request and say on G0/0, what protocol is running. I can't just say what protocol is running, even though the last request was what's on G0/0, right? You have to repeat it every time you want a response, right? The response don't know what you said previously. The response only knows what you're saying right now. You're saying what protocol is running. Protocol is running on what? I don't know what you're talking about. Even though the previous request was G0/0, this now request is brand new. We're not talking about what you asked me before, right? Or what the future you're going to ask me. We're talking about right now, what do you want? You have to be specific. That is stateless, right? You have to repeat it in full every time. What is the status of G0/0? Up. What is the protocol running on G0/0? OSPF, right? What is the IP address on G0/0? Right? You have to repeat what you want. You can't just think that it's going to automatically know what you said the previous statement. Okay, that's stateless, right? So then we talk about cacheable, right? So basically it's something that things are, do you want them to change or you don't want them to change? Do you want them to stay in the cache or do you want them to be deleted, right? And that's so we can, we won't have to resubmit the same request, right? So if we know that, let me see. Oh, here's cache, here's right here. Okay, cache will avoid full trip to server and allow less server work. So if we're saying, let me give you an example. Attempt to avoid resubmitting the same information. If I'm asking what's the status of G0/0, interface G0/0, and the server comes back and say it is up, right? I'm asking, it gives me a response, right? It can possibly cache that information. So maybe in a few hours, I want to say like, well, I did some changes. We reset the router. We powered it off, powered it back on. What's the status of G0/0? Now, the response, the request won't make a full trip to the server because that information is cached. So it's going to come back to the client in the middle and be like, oh, I already know it's up, right? And you kind of got to be a little worried with that because sometimes that information could be stale, right? So you probably will only want that information or that cached information to be good within a few hours, right? Maybe not days or weeks or months, right? Maybe days, but not weeks or months, because again, it can get a little convoluted, right? But that's what cacheable is, right? It is basically just attempting to hold information that won't necessarily change, so it doesn't, the server doesn't have to work and give you that response over and over and over again. So maybe the interface is not a good example. I'm going to say, what's the host name of the router, GA0296? Right? What's the host name of it? The host name is GA46. All right, that won't change, right? Unless we're actually going to change it. Which, why would we change it, right? Why are we changing the host names, over and over again? Like, this is the host name, right? We're going to keep that host name for probably as long as we have this network running, right? As long as the site name is in Georgia and the router that we're using is a 1946. I don't know if that's not a real router, but I'm just making up stuff at this point, right? That's something that can stay in the cache because the host name is not going to change, right? The interface will change, so I'm not going to say that can be in the cache because something can happen, right? Where the server's going to have to recalculate and be like, okay, well, it was down, but it's back up. So it's up, but it was down, okay? So if anything, that would be cache. Would be a better example would be like the host name, right? What is the host name of this router? This is the host name. We'll keep it in this cache because, again, that stuff is not really going to change. Okay, so that's cache. Uniform interface. Oh, one moment. I'm sorry, you guys. I just got this. All right. Delayed gratification. Okay, anyway, so uniform interface. So uniform interface is basically saying that there's a uniform way of interacting with a given server, right? Or type of application. So if you look down here, right, this is an example I was able to find of uniform interface. So no matter what we're using, whether we're using a phone, tablet, computer, laptop, or desktop, we're using SSH or a GUI, we're on this client, that client, it doesn't matter. We are going to use a uniform interface. We're going to use the same interface for all interactions, regardless of what I'm using, okay? Regardless of, again, if I'm using a different type of client. There's a uniform interface that's going to give, my API is going to talk through and give me information. Okay, now uniform interface, it does have some like subcategories to it. I believe it's 4 of them. Something like identification, manipulation, representation, something in that sort. Which when you go down in the book, it may or may not talk about that, but that's something that they may mention in the CCNA. Definitely make sure you take note on that. However, as long as you know that uniform interface is basically the keep it simple, right? We're going to make sure that we use the same interface for all interactions, servers on the node, right? That's uniform interface. We just want to keep it simple, right? So we talked about that. Now, layered. Layered means that it could be multiple layers that we're going to use as we expand this interface, right? Because we're going to expand it. So there's multiple layers to it, and it doesn't matter what's in the middle. The client and the server can still give the immediate response, right? The client can still send immediate request, and the server is still going to give you response, right? So the request between the client and the server, they don't really need to know if they're communicating with the actual server. They just need to know I'm getting this information, right? So this is a great example here, proxy, right? So proxies can be useful when we're like load balancing, right? And security checks. That's usually we will have some type of proxy in the middle of our client and server ordeal, right? So it's good for like load balancing, security, all that stuff. Now, a proxy kind of acts like a server in a sense, right? So when the client is, when the client initially sends the request, right, the proxy is going to get it. And the proxy is going to act like it's going to relay the message to the server. And the server is going to obviously relay the message to the proxy, who's going to relay the message to the client. Okay, so looking at here, we have our client, right? Our client's going to we're going to send a request. obviously is going to go to the proxy. The proxy is going to say, it says, even though there's a proxy, the contract between the client and the server are, the same. So the proxy is going to get that request. Proxy going to say, oh, you want a request? This is what they're asking. The server will say, okay, well, here's the response, and the proxy is going to send it to the client. Okay, that's basically layered, meaning that you can have multiple layers and the client and server is still going to communicate, right? Still going to translate them HTTP requests just in another protocol, right? And it's going to basically package up that request, translate into a response, and send it back as a HTTP, right? The client won't know the difference. The server won't know the difference. It's just the proxy doing the work in the middle, right? So the client can like simply treat this gateway or this proxy as a regular server, right? And I mean, an example in networking, it would be a gateway or a gateway or a router, right? We use this gateway as a system to like download FTP server. So this can be like our gateway, right? Which is a router, same difference. And this is our server, and this is our client. This is us as at a computer, and this is our server, right? So when we want to send a request, right, to get some information, our data is going to flow to this proxy, aka the gateway, aka the router, and the router is going to say, okay, well, you can get through. Let me send you over to the server. The server is going to say, okay, this is what you want. Let me give it to you, right? It's going to be an HTTP, but it's going to go in a data packet to this gateway, and the gateway is going to send it back to the client in the form of HTTP. Okay, that's layered, right? That's what layer is saying. There can be layers, right? Maybe there's another proxy, and then it's to the server, right? Again, it's multiple layers because we want to expand this interface. And then last one, code on demand, which is actually optional. It's not a required rule to become, for an API to become a REST API, but it is there. It's an optional feature. And servers can basically provide this code to the client, right, to execute, right? And basically this happens in like an HTML field. I believe it's like in the HTML script field, something in that sort. We'll kind of go over maybe HTML later on, possibly. Maybe it may be helpful if you guys want to do it. It depends on how many requests I get. Then I will probably come out with an HTML, like either mini course or just addition to this course. I'm not sure yet. We'll see. But anyway, it's a code on demand. It's an optional feature. And the HTML script tag is basically has this code for the client. So when this HTML document that has this tag is loaded, the browser, the web browser automatically fetches this type of code, whether it's from like JavaScript or something in that sort, from the server and executes it locally, right? So it's code on demand. I wasn't able to find an image on code on demand, but just know that it's a specific code in this HTML document that the browser will automatically fetch for you, and it will execute on your end, right? And that's all that really does. Again, it is optional, but just know that is exactly what it sounds like, code on demand. You can get a JavaScript code in this HTML document to run on your computer, right? So we talked about that. So those are the 6 rules, one being optional, which is this one, for an API to be considered a REST API, okay? These are definitely notes you want to take down, okay? Because they will ask you, what are some rules that make up a REST API, a REST-based API, and at least you know the 6. Then the combinations of it, you may only have to choose 3, but the combinations of it, you want to at least make sure they're one of these 6. Okay. All right, let's move it along. Now, going deeper into RESTful architecture, right? Because we want to better understand it, we have to go in onto CRUD, right? CRUD. Right? CRUD is a cycle for keeping records current and permanent, right? And when we're talking about RESTful APIs, CRUD is the standardized use of HTTP action verbs, right? So HTTP action verbs, we're going to create, we're going to read, update, and delete, okay? So how do we create it? We're going to either post, that's how we create something. We say post, right? Or HTTP, the action is post. If we want to read something, the HTTP action is get. Okay. And if we wanted to update something, the HTTP HTTP action verb is put. Or sometimes you can say, well, it's put and you can say patch, right? Put something or patch something. And then of course, delete, right? The HTTP verb is going to delete it, okay? So with HTTP, right, with these requests, we're either going to create a request, we're going to post something, we're going to read a request, right? We want to get something, right? Let me get this. I'm going to get youtube.com, okay? Let me update something. I'm going to use post or patch, okay? And delete is delete, right? I don't want it. So I got this image because it actually gives you a more visual aspect of actually get and post and put. So we have our URI, right? Our API is in there. And our URI, we're talking about employees. So our verb, we want to get. What do we want to get? We want to get a list of employees. So this is what this URI is saying. It's saying employees, and we're using the get verb, right? We're going to use the get method, and it's going to, okay, let me give you your employees, a list of employees in the company, a list of interfaces, a list of active devices, a list of switches, whatever, you're getting a list of something. Then we have another URI, right? API, employees, and maybe this URI is one. I want to get it, right? So what it's going to do is it's going to get employees with an ID that equals one. Maybe one is in their ID, right? In their identification number, or one is what their identification number, employee ID starts with, or whatever one is specified, and it's all proprietary and specific to your company, right? So again, maybe I want to get all the interfaces that are down, get all the interfaces that are attached to, that are running OSPF. I don't know, right? You want to get something. Then another URI that you're going to put in the field, another API is employees, but you want to post, right? This time you want to create. Okay, so what do you want to create? Create a new employee. Okay, so someone just got hired on, you want to post, right? You want to create this new employee a profile. Okay, maybe you want to create another interface. Maybe you want to create, I don't know, so many things you can create, right? But that's what post is for. Then again, let's just say we have our URI with our API, employees, and it's another one, but we're going to do put now, right? So put is what? Update. Okay, so what do we want to do? We want to update employees with ID number one. Okay, so we can get employees one, which is get employees with ID one, or we can put with employees one, which is update employees with the ID of one. Okay, we can get employees, which is a list of employees, or we can post employees, which is create a new employee. Okay, these are our HTTP action verbs, right? That we're going to use with our APIs to get request information through HTTP, and we're going to request it, and we're going to get a response via HTTP as well. Okay, this is very, very important that you understand CRUD and understand the post, get, put, patch, delete. Okay, and what it do. Well, if I decide to post something, what is that? Right, I'm creating it. If I decide to get something, when you get it, what do? You're going to read it, right? If I want to put or patch, what does that sound like? Sounds like an update, because I'm putting this in place or I'm patching this up. And then delete is delete. I mean, you can't get delete wrong. Okay, so get, put, post, get, put, patch, delete, right? It's in the CRUD, right? CRUD. CRUD is create, read, update, delete. Okay, standardized use of HTTP action verbs. All right, this is something you definitely want to make sure that you're note taking. You will talk about this in the chapter. I don't know, I believe it's chapter 18 or 19, or maybe even both. I actually didn't look at the chapters today. Sorry, you guys. But in the book, definitely go to chapter 18, chapter 19, or you can just copy and paste in the spine the topic that we're talking about, the little fine magnifying glass, and it'll pop up everywhere in the book where it has this information. And you just go through it from there. Okay. So before we even stop, right, because we talked about RESTful APIs, this is just the basic understanding of it. You may get a little more in depth in the book, because the Cisco book will definitely give you a lot more. However, this is a good enough for you to get your head wrapped around what we are talking about today, right? So you're not totally lost, okay? Now, before we even stop this lesson, I want to go into JSON, right? Encoded data, we want to learn how to interpret it, right? So JSON is the abbreviation for JavaScript object notation, right? So it's JavaScript object notation. Y'all know I don't know how to spell notation, okay? Let me get that out. Notation. Okay, notation. That's what JSON is. And it's basically like a lightweight data that's interchanged like this type of format that's user-friendly, right? So like this lightweight format that's easy to read by not only us, but also the computers, right? So with JSON, you can kind of easily guess what they're talking about, what's going on in the file, without having to be like, oh, I am, I'm proficient in JSON and JavaScript, so I know exactly what this means and that means something else. No, it's kind of like plain text, almost like how Python is kind of like plain text. This is JSON. It's very easy. So this is kind of what JSON will look like, right? So it'll come back, it'll have a name, right? Jane Doe, right? Jane Doe is a name, right? That's easy to read. Salary, right? 9,000, right? Skills, the skills is Raspberry Pi, machine learning, web development. Those are some good skills that Jane has, actually. And then email, right? Projects, what have she done or what project she's working on, data Python mining, Python data science. Those are some good skills Jane has. But nonetheless, this is what JSON data looks like, right? Pretty simple. The only big things you would have to pay attention to is maybe this right here. That's like a bracket, one of those brackets. As you can see, it looks like squiggly. I'm bad at that. Squiggly, right? One of those. And that basically means a object, right? AKA a dictionary. How you spell dictionary? Right? This is what this wiggly line means. It means a dictionary. So we have the opening dictionary and the closing dictionary, right? Closing dictionary. And this is what's in our dictionary: our name, salary, skills, email, projects, okay? Another thing you may want to pay attention to is this guy, right? This bracket, simple. And I'm looking at my keyboard, they're on the same keys, right? These two, this is the top one, so you have to press like shift to use that. Then we have the bottom one, which is automatic, okay? This means a array, right? This is called an array. And it means a list, right? Array, list, object is a dictionary. That's kind of how I look at it. So an array with the list, as you can see here, we have an array, and it's a list. It's a list of what? Skills. So we have Raspberry Pi, machine learning, and web development. Close the list. Now we're going to open up another list, And she has projects on her belt. She has Python data mining, Python data science, and then close the list. Okay, that's probably really the only two things that you probably have to decode. Outside of that, it's pretty self-explanatory what's happening in this data, right? We kind of know, like, oh, we're getting Jane Doe's information, right? And the information is as follows: name, salary, skills, email, projects. Okay, so the client is going to request information, right, in the form of JSON data, right? And it's going to do one of these methods. Is it going to get, right, post, put, or delete, right? And so as it follows through the API is going to send it to the server, right, as an HTTP request, right? And the server to send a response, right, as an HTTP response, right, back in a JSON data to your client. And this is what it's going to show up. It's going to show up something that looks like this. Now, it can say something as simple as interface G0/0, status up, protocol up, OSPF, right? These are what's connected to this interface. These are the IP addresses on this interface. The whole bunch of other stuff, I don't know, but whatever has to deal with the interface or router, what's going on with this router or this switch or this networking device, whatever you can think of, because we're still in network engineering. Yes, it seems like we're now turning into software developers, but this is the information that we're going to use as we automate our networks, right? Because automation, programmability is the new wave. Okay, and if you don't know this, then no one wants you to work for them. And what are we all about? We're all about making that money. So if we want to make that money, we need to do things that are trending, that are the future. And JSON, Python, JavaScript, these dev tools, these developer tools are what's going to get us paid. Okay, so again, let me erase this here. Erase. Chapter 18, 19, one of the two. I don't know. I don't remember. It's in the Cisco book. Make sure that you read the Cisco book. Take notes. Do your flashcards. Tomorrow is our last lesson, right? It's our last lesson in this automation section, and also our last lesson in as far as the CCNA exam topics are concerned, right? I may come out with a couple more lessons that probably deals with HTML and CSS. Definitely, I'll come out with a lesson. We'll probably do a live, or it'll probably be like pre-recorded, who knows, on LinkedIn. How are we going to get our LinkedIn profiles together so we can actually get a job, right? I want you guys to definitely set up a one-on-one. I'll let you know when one-on-ones are open. I'll be reaching out to everyone individually to see where you guys are at. And so we can see how we can make sure that you increase your income, because that's all that this is about, right? Whether you actually take this CCNA or not, the goal is to still increase your income by tech, right? Maybe it's not by tech. Maybe I can get you into a job that, something that you feel is more your speed. I don't know, but I want to have this one-on-one with you so we can ensure that we get you more money in your pocket, period. All right. So before we close out, obviously we do have a lab. Let me stop here. So first, I want to ensure discard. We don't need all that. Take that down. So I want to ensure, let me take that down. That previous lesson, we talked about Python. We did Python, and I had to fix my code, and I didn't want to fix it in front of y'all because we're already an hour. I try to make these lessons like no more than an hour long. So let's just go ahead. I fixed my code. Basically, it was just indentations because I told you how I copied and pasted was wrong. You have to indent a certain way. So let me just show y'all in my notepad, right? This is what I had. Again, some of the stuff was indented too much or not indented enough. The indentation is very, very important. So I had to go back and actually fix it, which didn't take me too long. I think it took me less than an hour, probably like 45 minutes. But as you can see, it's nice and indented, all nice and even, right? Good. Oh, maybe that's not the one. Let's see. We had number game. Okay, maybe it's guess or something. I don't know, but just know that I fixed my code. So first thing I want to do is let's go into PowerShell. We could do Git Bash. I'm just a PowerShell freak. So whichever terminal you want to use, whether it's the command, whether it's PowerShell or Git Bash, use it, whatever's comfortable for you. Again, for me, I just love PowerShell. I've always been using it. So why not continue, right? There's no wrong one to use or right one to use. So since it's on my desktop, let me just make sure it's on my desktop. So I'm gonna CD, right? Change directory. I'm gonna do desktop, and it gets me to my desktop. Now I actually want to go into number game. So I'm gonna do pi number game. I think this is what I want, or maybe it was the blockchain that I want to show you guys, right? It doesn't matter. So I'm going to my number game. This is my code. And I have to pull it up, pi, which is Python, the name of the game, the name of the file, number game. We're always going to end it with .py. So now my code came up. Let me just show you again. This is my code, right? Number guessing game, okay? This is what it looks like. Now, as I put it in to run it, this is what it came up. Hello, traveler. Welcome to the game of guesses. What is your name? I'm gonna say my name is Jessica. Enter. Hi, Jessica. Would you like to play the guessing game? Of course I do. So I'm gonna say yes. Enter. And it's okay. There's currently no high score. It's yours for the taking. Pick a number between 1 and 10. I'm gonna pick 9. It's lower. Pick another number between 1 and 10. It's lower than 9. I'm gonna say 5. It's higher than 5. Pick another number between 1 and 10. I'm gonna say 7. It's lower, so it gotta be 6. So I picked 5 and I picked 7. It wasn't it, so it gotta be 6. Nice, you got it. It took you 4 attempts. Would you like to play again? And that's the game, right? Pretty simple. That's the game. I can say no. I can say yes. Let's go back through it. All right, current high score is 4 attempts. Pick a number between 1 and 10, 5. It's lower, 3. It's higher, 4. 3 attempts. So I got better at it. I did take 4 attempts and I took 3 attempts. I don't want to play again. Whatever. So I'm going to say no. And it's going to say the current high score is 3 attempts. That's cool. Have a good one. And I'm back at my desktop to do what I want to do. Right? Pretty freaking cool. Let's see if I can pull up my blockchain. So Python blockchain. Ooh, let me spell it right. Chain 1.py. Okay. Let me clear that up so we can go see it at the top. Okay, so it says enter your transaction amount. So we know that blockchain is just a ledger, right? So the blockchain is a ledger. It's a ledger to say, it's like public access of what you spent, what you received, what you have, you know? So on this blockchain, I only did the basics. So I'm not a blockchain expert. Don't come to me asking about it. So I just did the basic, which is ledgering, right? There's no hashing involved to hash. So no, it's like no security, right? It's just a ledger. So enter your transaction amount. Let's just say today, while I did make $5.80 in the crypto market, not much, but I made $5 crypto. Enter, and it says choose an option. Choose 1 for adding a new transaction. Choose 2 for printing the blockchain. 3 if you want to manipulate the data, and choose anything else if you want to quit. So let's say I want to add another transaction. So I actually made $6.18 in the stock market. Nothing much, but I made some money, right? Oh, hold on, no. I have to choose 1 for adding a new transaction. And then I made $6.18 in the market. So let me enter. Cool. Let's just say that my drop shipping store only got 1 sale. After paying the bill off that 1 sale, I only net $10. Oh, let me choose 1 to add a new transaction. I only made $10, right? Enter. So now I added the amounts that I made today. And it says I want to print my blockchain. I want to choose the number 2 because I want to print the blockchain to see my transactions. So I'm going to say 2, enter, and it's going to give me my block. So my first block was 5.8, right? That's what I made in my crypto. Let me come up here. My second block is 6.18. That's how much I made in the stocks. And then my third block is 10, is what I made in my drop shipping store. So it's telling me my ledger, this is what I made. Okay. I can choose 3 to manipulate my data, right? 3. And it says blockchain manipulated, right? And that's it. That's as far as I got. As you can see, it has ended back at my desktop. That's as far as I got with this blockchain code. I worked very hard on this. It took me a very long time to get this. If you guys want to work on this project with me, which is from here, we have the ledger. So now we need to learn how to hash it, right? Get security on this ledger. And again, I learn as I go. So it's not like, oh, I know the project, I know what to do. Let's go ahead and do this. No, I just know that a blockchain, you have your ledger, the ledger needs security and it's supposed to spit back information at you. So as I learn how to do that, I learn more about blockchain and what it actually is used for. So if you guys want to hop on this project with me, then just Slack me. I can definitely give you my resources that I'm learning from, and we could just work on this code and probably make something big, right? I'm also working on a machine learning project, basically delving into machine learning so I can build some type of AI. So if you guys want to hop on that project with me too, come on. This project is good for experience. You can definitely put this on your resume if you're not in a rush to just get into something now. If you feel like, yeah, let me play around to enhance my skills, or even if you are in a rush, you got this job and you want to learn more, machine learning is good. Again, it's just a project. It's not like a paid job or anything. So this is all off of your free time. But the reward is great. You put your free time in it, build it. We build this together. We actually come out with an AI or with our own blockchain. That's all I can say, right? That's all right? So it could take us this rest of the year. It could take us 2 years. Who knows? But just know that when we build it, right? So if you want to hop on any of these projects with me, or if you feel like there's another project that you're working on that you want some help, just feel free to Slack me and we can work together, because tech is the future. And if we want to make sure that we're able to, break generational curses, leave our kids with something, be able to take care of our parents who took care of us, this is what we need to do. We need to put in the work and increase that income, right? Before we go, I definitely want you guys as a lab, because I was just showing off. As a lab, I want you guys to go to REST API fundamentals. And if you have time, you can do introduction to model-driven programmability. But at least for today, read the chapters, REST API fundamentals. And if you want to go and revert back to Python a little bit, since you saw what I did, then feel free. Okay, tomorrow we will definitely hop on, get a little bit more about some developer tools like Chef, Ansible, Puppet, and then that'll be it. We'll take our final exam and start preparing to take the CCNA exam, as well as increase our income by getting interviews and getting a job. But before we even do that, we definitely need to get our LinkedIn profile together. Okay, so questions, comments, concerns, you already know what to do. Reach out to me in Slack. You can definitely DM me on Instagram. I do have a couple people that I'm talking to there, and I found like it's still easy. Emails, stop it. Stop sending me emails. Only send me Slack DMs or talk in any of the channels in Slack that's specific to the conversation that you want to have. I'm here. There's other people here that will definitely talk to you and tell you information that they have and they can share. So don't be shy, all right? Say what you need to say in the channels. You don't always have to DM me. So yeah.